Hi everyone, today we are going to be talking about section 11.2, and this is about how to find the area of circles, which is going to be a review lesson. For the most part, you have found area of circles before, and we're also going to talk about how to find the area of something called a sector, and that might be new information, so that might be something you've never done before. So before we begin, just to point this out, you will need a calculator for today's lesson. Because we're dealing with circles, we are going to be using the number pi. You might remember that from middle school. And pi is a number. It's approximately 3.14, but I don't want you to use 3.14, not in this class. That might be what you did in middle school, but in this class, we're actually going to use the pi button in our calculator so that we can get a more exact answer. So if you don't have a calculator, you're going to want to get up and get one right now. Make sure you have a calculator. If we need to pause the video, you can pause the video, but I want to make sure you have a calculator before we start the notes. Okay, so we're going to start with some review. Today we're going to find the area of circles. Last time we talked about how to find the area of some basic two-dimensional shapes, but we did not talk about circles. So today we're going to focus on circles. And this might be something that you remember from middle school. The formula for the area of a circle is pi times the radius squared. So it's pi r squared, which is a pretty basic formula. And as long as you have a calculator, it's really easy to calculate. All you need is the radius. So let's do a couple examples. So here's the first circle. The radius here is 12. So the area of this circle is just going to be pi 12 squared. Now I'm going to show you two ways to write out your answer here. Sometimes I'm going to ask you for something called an exact answer. An exact answer is something where you're not going to use a decimal, because if you were to type this into your calculator, if you used the pi button, you're going to get a decimal and you're going to have to round that decimal, because pi is a number that goes on forever. It never repeats itself. It doesn't have any sort of pattern. So you're going to get crazy decimals when you do these. So sometimes I'm going to ask you for an exact answer instead of a rounded answer. And that means just do the 12 squared, right? That's 144. And then it would be 144 times pi, but you could just leave it like this instead of actually multiplying it by pi. So it's 144 pi meters squared. This is kind of similar to how sometimes when we get radicals, remember sometimes we'll get things like the square root of 113. And sometimes I'll ask that you leave it as a radical instead of actually square rooting it, just so we have exact answers, right? Same kind of thing here. So the exact answer would be 144 pi. That's the area of this circle, 144 pi. But if you want to get a more, if you want to get an estimate of what the area actually is, you can multiply that out in your calculator. So in the calculator, you can type in 144 times pi, or you can type it in exactly how it looked in the beginning. You can type pi 12 squared and just hit enter, and it should be approximately 452.4 square meters. And I want you to go ahead and try to type that to make sure you're getting this answer. I want you to find the pi button in your calculator. If you don't know where that button is, I'm going to show you real quick a calculator picture here so you can see what that looks like. So I have, here I have a screenshot of a calculator screen, and the pi button is right here. It's kind of hard to see. It's right above this little caret symbol, that little up arrow. So you're going to have to hit the second button first and then hit that caret symbol, and you'll get the pi. So when you type that in your calculator, just hit second caret, and then you can type 12 squared or whatever, and then it should multiply out to equal about 452.4. Okay, so again, you can just type in your calculator, or sometimes I'll ask for the exact answer and you can just leave the pi in there. All right, let's do a few more examples. So down here, this is a diameter this time, and remember the formula is pi r squared, so we don't want to use 18. The radius here would be 9, so you're going to do pi 9 squared. And then that you can just type that in your calculator. It should be about 254.5 square inches. So that would be a rounded answer. Again, if you wanted an exact answer, it would be 81 pi. You would just do the 9 squared. All right, next one, 2.8 is the radius. So it's just pi times 2.8 squared. Again, you can just type that right into your calculator. It should be about 24.6 square feet. And then finally, another one here, we have a diameter, so we're not going to use 10.2, we're going to use half of that, so 5.1. So pi times 5.1 squared, it's about 81.7. Okay, so that's kind of the basics. This is stuff that you should have done before. Now we're going to use the area formula to go backwards and find a missing measure. So we did this the other day too when we worked with the area formulas for basic shapes. So let's go ahead and read through this first example. It says, find the radius of a circle that has an area of 380.13. So the formula for circles, area of circles, is pi r squared. We know that the area is 380.13, and we do not know the radius. So we're just going to substitute the area for A, and we're going to solve this equation for R. So let's go ahead and try to do that. We're just going to use our algebra skills to solve for R. So the first thing I would do is get rid of this pi. So you can divide both sides of this equation by pi. So then you would have r squared is equal to, now when you type this in your calculator, you are going to get a big decimal, right? I recommend you keep at least 4 decimal places, or better yet, just leave all that in your calculator screen, and then you can just work with the math inside your calculator to get a really accurate answer. Okay, so now we're going to square root both sides, because that's how you undo squaring something, right? So the radius is going to equal the square root of this, which is approximately 11. So we'll round it to 11. We'll say the radius is 11 inches. Notice I did not put square on the inches because it's not an area. This is just a length, so it should be normal units. Okay, the next one, it says find the diameter of a circle that has an area of this. Okay, so this is kind of the same thing as the previous problem, except we're finding a diameter instead of a radius. But we're going to solve it the same way. So we're going to start by taking our area formula, and we're going to plug in the area. So the area is 615.75, and that's going to equal pi r squared. So we're going to solve this one the same way. You can divide both sides by pi, and you can do that right in your calculator. It should be about 195. Again, it's going to have lots of decimals, right? Just leave them all in your calculator. Then we can square root both sides, and you should be getting approximately 14, but they want the diameter, right? So remember, in a circle, a diameter is just 2 of the radius. So you're just going to times this by 2. So the diameter would equal 28 centimeters. Okay, go ahead and turn the page. We're going to do a couple more examples. All right, so these ones are kind of similar, except the area that they give you has a pi in the answer. So I'm going to show you how to deal with that. So it says find the radius of a circle that has an area of 121 pi. So same thing here. The formula for area is pi r squared. So we're going to replace A with 121 pi. And then we're going to solve for r, just like we did before. So same thing, we're going to divide both sides by pi. Now in this example, you don't need to put that in your calculator, because see how there's already a pi in the area? These are just going to cancel each other out. Same thing over here. So you're just going to have 121 equals r squared, and then you could just square root both sides to get the radius. So the radius would be the square root of 121, which is 11. Okay, the next one's similar to that. It's got a pi in the answer, right? So it says find the diameter of a circle with an area of this. So same thing, we're going to say that 56.25 pi equals pi r squared. And then we will divide both sides by pi again. So these will cancel. So 56.25 equals r squared. Then we can square root both sides. So r is going to equal 7.5. But they want the diameter, so we're going to double that. We're going to times it by 2. So the diameter is going to be 15. Okay, now we're going to talk about something called sectors. So a sector is kind of like just a portion of the circle. And we're going to work on how to find the area of only this little piece of the circle. So instead of finding the whole circle, we're just going to find a portion of it. Think of it as like a slice of pie, right? So that's called a sector. That's the vocab. So a sector is a section of a circle that's bounded by a central angle. So that's some vocab from the last chapter. This right here, this purple angle that I'm highlighting, that's called a central angle. And it also has an intercepted arc, which would be this green arc right here. So that central angle and that arc, it creates the sector. So again, think of the sector as like a slice of pizza or a slice of pie, right? It's just like a part of the circle. So to find the area of a sector, you're still going to be doing the basic area formula. So the area of a circle, remember, is pi r squared. But we don't want the whole circle. We only want part of the circle. Now, circles are 360 degrees, right? So this central angle represents part of that. It represents x out of 360, right? So the whole circle is 360, so this little angle is just part of that 360. So if we wanted to find the area of only that portion, we would still do pi r squared. So I'm going to write the formula here. So we're still going to do pi r squared. However, we're going to multiply it by the percentage of the circle that we actually want to find. So here's what the formula looks like. It says x over 360 times pi r squared. And this, again, this just represents the portion of the circle that we want. So whatever that central angle is, it's always out of 360 because it's a circle. So let's go ahead and take a look at some examples here. So they want the area of the shaded sector for each of these. So first off, they're telling us that BC is 16. That's a radius. So the radius is 16. And then the portion of the circle that we want is this 51-degree part of the circle. So the formula for a sector is this. It's x over 360 times pi r squared. So the angle that we have is 51. So we're going to do 51 over 360 times pi 16 squared. And you're just going to put that right into your calculator. So as long as you're careful, you should be able to type all this into the calculator. There is a fraction button in your calculator if you want to type it that way. You could enter this in as a fraction. Another way that you could enter it so that it makes for easy calculations, you can think of it as this: 51 times pi 16 squared, all divided by 360. That's how fractions work. That would mean the same thing. So you could do 51 times this, hit enter in your calculator, and then you just divide by 360. If you do this correctly, you should be getting approximately 113.9, and I want you to actually do it. So take a minute right now, take that calculator. I want you to type this in until you can get this as an answer, because if you don't know how to type these in correctly, you're not going to be able to get the right answer. Okay, so you can either use the fraction button or you can do it in 2 steps like this. Okay, let's take a look at the next example. So we want the area of the shaded region. However, we don't have the angle of that shaded region, right? The angle that we have is this 126, but you could easily get the angle for that shaded region because remember, circles are 360. So you can just do 360 minus 126. That's going to give us 234 degrees. So that's what this measurement here is, 234 degrees. And that's the portion of the circle that we want. So we could do 234 out of 360 times the area formula, which would be pi r squared. So 13 is the radius here. So pi 13 squared. So again, type that into your calculator, however you did it for the last one. You should be getting approximately 345.1. Okay, when you're ready, go ahead and turn the page. We're going to do some more examples. Okay, so at the top of this page, we have some you try problems, and I want you to try those. So we can go ahead and pause the video. You are going to find the area of the small sector, which is this piece right here. So on my screen, it's the orange piece. On your screen, it would, I know it's black and white, but it would be this little 70-degree portion. And then you're also going to find the area of the larger sector, which is that blue area over here. So go ahead and try those on your own. You can pause the video, and then once it looks like everybody's done, we can go ahead and press play and get the answers. Okay, so here's the answers to these two problems here. The small sector is the 70-degree portion, so you can do 70 out of 360 times pi 8 squared because the radius is 8. And then the larger sector, you're going to have to get that angle measurement. So you can just do 360 minus 70, and that leaves us with 290. So it's 290 out of 360 times pi r squared, which is about 162. Okay, these next few examples are pretty similar. You just have to be careful. You have to really look at what they're asking you for. So in this one, it says, find the area of the sector formed by the major arc. So that's some vocabulary that you need to remember from the last chapter. So in this picture, we have two different arcs here. We have the minor arc, which is the 120. Remember, minor arcs are going to be less than 180. And then the other side of the circle, all of this right here, that would be the major arc. So that's what we want to figure out. So we're going to do 360 minus 120 just to figure out what that arc is. And that would be 240. So the area of that sector would be 240 out of 360 times pi r squared. So pi 14 squared, because the radius here is 14. And if you type that in, you should be getting about 410.5. Okay, the next one, it says find the area of the circle. This one's a little different. So in this picture, they're giving you an area here, and that area represents the sector area. And what they're asking you is, okay, find the area of the whole entire circle. So there's a couple ways to go about doing this, but here's how I like to think of it. That 35 square meters, that represents only 40 degrees of the circle, right? So if I split these up into a bunch of 40-degree sections here, each of them would be 35 square meters when we're talking about area. So if I knew how many of these fit into a 360-degree circle, well, then we could just take 35 and we could times it by however many there are, right? So what I would do is just do 360 divided by 40 degrees just to see how many of those sectors would actually fit in the circle, and that gives us 9. So I want 9 of these 35 square meter areas. So you can just do 9 times 35. And that would give you the area of the whole entire circle, which would be 315 square meters. Okay, so the next problem is kind of similar. So they're giving you the area of the sector, and that sector is only 135 degrees of the circle. So basically, I want to know how many of these sectors would actually fit in this circle. So we're going to do 360 divided by 135, and that gives us, if this one's going to be a decimal, that gives us 2.6 repeating. I would just leave that in your calculator screen, right? Leave all those decimals in your calculator, and then you can times that by 48 because that was the area of one of the sectors. So if you do that times 48, you get 128. So that would be the area of the whole circle, 128. All right, in these examples here, we're finding the area of multiple sectors. So it's not too bad. So in that first one, we are looking at 2 sectors. Now those sectors are identical. And the reason why we know they're identical is because of something we learned a long time ago in this class. We have vertical angles here. So that means that this angle is also 113. So whatever the area of this sector is, this sector would also be the same thing. Now there's 2 different ways you could go about this. You could find the area of one sector, and then just double it because there's two of them. Or you could just combine these angles right away. So 113 plus 113, that's 226. So basically, I want 226 out of this 360 degrees, and we're going to multiply that by the area formula, which is pi r squared. Now, the radius here is not 30. See how it says xy? Xy is 30. That's the diameter. So the radius would be half of that. It would be 15. So we're going to do pi 15 squared here. And this setup here, this is going to give me the total area of both of these sectors combined. And that's what we want. So you can type that into your calculator, and it should be about 443.7. Okay, the next example is similar to that, but it is a little bit different because the angle that they're giving us is not the shaded angle, right? It's just in this non-shaded part. So now we do have vertical angles again. So this is also 143. There's a couple different ways you could do this. You could just do 360 minus both of these, and whatever you have left over, that's going to be the portion of the circle that we want, right? So if you do 360 minus 143 and another 143, you're going to get 74. So 74 degrees is what's left of the circle. That means each of these were 37 degrees because 37 plus 37 is 74. So if we want the area of the shaded portion, we're going to use a 74 degree portion because that's what this would represent. So let's see if we have the radius. The radius here, it says EB is 10.4. That is actually a radius this time, right? So we're going to use 10.4. So the area of this shaded region would be 74 out of 360 times pi 10.4 squared. And again, you can just type that right into your calculators. You should be getting about 69.8. Okay, so in the next example, this one's similar. We have two shaded portions and we can just add them together. So we know that this one's 58. Now this one over here is half the circle. That would have to be 180. That's because this is a diameter here, right? So what we can do is just do these two added together. So 180 plus 58, that's going to give us 238. So that is the portion of the circle that we're trying to figure out. So we have 238 out of 360, and we're going to multiply that by pi r squared. Let's see if we have the radius. They're telling us that JM is 10. That's the whole thing. So that's not the radius. That's the diameter. The radius would be 5. So we can do pi 5 squared here. And then you just type that in your calculators, and you will have your area. Okay, so that should be about 51.9. Okay, go ahead and turn to the last page. We're going to talk about composite area now. Okay, so we talked about this a little bit in the last lesson. Composite area means that you have kind of a strange looking shape, and it's created by two different shapes put together. So we're going to find the area of each piece, and then we are going to add those together. So in this shape, this right here is a semicircle, right? It's half of a circle. And then over here, we have a triangle. So we're going to find the area of each of these. For a semicircle, you're going to do pi r squared, but you're going to divide it by 2 because it's only half the circle. And then for the triangle, if you remember from last time, triangles are 1/2 base times height. So we're going to calculate these two areas. Let's start with the triangle, because in the triangle, we already have the base and the height. It would just be 7 and 7. So it'd be 1/2 of 7 times 7, which is half of 49, which is 24.5. So that's the area of the triangle. Now we're going to find the circle. So the circle is going to be pi r squared divided by 2. Now the radius here is not 7, right? That's like this whole piece. So we can split that in half. The radius would be 3.5. So we're going to do pi times 3.5 squared. And then you're going to divide that whole thing by 2. And it's about 19.2. So the total area would be these two pieces added together. So 24.5 plus 19.2, which is 43.7. So that is the total area of this shape. Okay, the next example is kind of similar, except we're not going to be adding the areas, we're going to be subtracting. This is one of those shaded region problems. So it looks like we have this square on the outside, and there's 4 circles that are being cut out of it. So what you're going to do is find the area of the square. That part's easy, right? It's just length times width. So it's 20 times 20. So that is 400. And then we're going to subtract 4 of these circles. Now, the hard part about this problem is finding the radius of these circles, because you're going to need that to find the area. So let's look at that. Now, we know that all of these circles are equal because they've marked that the radii are all congruent. So we just need to figure out what that radius is. Now, if we look at the picture here, we know that the length, I'm going to clean this up a little bit. The length of this bottom side is 20. Okay, I'm going to zoom in on this. The length of that bottom side is 20. Now remember, every circle, all radii are congruent. So this is another radius. It would have to be congruent to this one. And then over here, I can draw another radius over here that's also congruent to this one. So the length from here all the way to here is 4 of the radii, right? And it's also equal to 20. We know that this whole length measures 20. So if each of these are congruent, you can just do 20 divided by 4, and that means each of these would have to be 5. So the radius of those circles is 5. So you can do pi 5 squared. Now, whatever you get for that, you're going to want to do that times 4. So if you want, in your calculator, you can just put it in like this. We want 4 of these circles. So 4 times pi 5 squared. And that is approximately 314.2. Now for this problem, we're not adding these together, we are subtracting these because we want to find the area of only that shaded portion. So we'll just do 400 minus 314.2, and that leaves us with 85.8. All right, that is it for the notes. You can go ahead and start the homework.